In this video, we are going to talk about trigonometric ratios of complementary angles. So we will talk about trigonometric, T-R-I-G-O-N-O-M-E-T-R-I-C, trigonometric ratios of complementary angles. So first thing first, what I want to do, I want to talk about the complementary angle. So let's consider a right triangle. So I'm going to consider a right triangle. This is my right triangle. A, B, C. And as you can see, the triangle is right at angle C. Right? So the side opposite to right angle is this side, which is AV, and I'm going to call it hypotenuse. If I take angle A as my reference angle, and I'm taking that reference angle as theta, then this side will be my opposite and this side AC, this one, will be my adjacent. Alright? Now, the next thing I want to ask, what is the sum of all the three angles of a triangle? So as we know, sum of all the three angles of a triangle is, I'm going to write angle A plus angle B plus angle C. We all know that it's 180 degrees, right? Look at angle C. Angle C is 90 degrees, so I'm going to replace C by 90. So I will write angle A plus angle B plus 90 degrees, because C is 90, is equal to 180 degrees. So in order to find the value of A plus B, what I'm going to do, I'm going to subtract 90 degrees from both sides. And if I subtract 90 degrees from both sides, this will be cancelled out. And on my left hand side, I have angle A plus angle B, that is equal to 180 minus 90 is 90 degrees. Alright? Okay. Now, let's look at the triangle one more time. If you look at the triangle one more time, A is theta. So, we can replace angle A by theta. But now let's look at this expression one more time. So, as you can see, A plus B is 90 degrees, which means what? Angle A and angle B are complementary, T-A-R-Y, complementary angles. Again, let me repeat it. A plus B is 90 degrees, so angle A and angle B are known as complementary angles, because the basic definition of complementary angle is if the sum of two angles are 90 degrees, then the two angles are complementary. So as you can see, A plus B is 90, so A and B are complementary angles. Alright? Now, as you can see, A is theta, so I'm going to replace A by theta. So I will write theta plus angle B is equal to 90 degrees. And if I want to find the value of angle B, what I need to do? I need to subtract theta from both sides. I'm going to subtract theta from both sides. And if I do that, I have angle B is equal to 90 degrees minus theta. Alright? So, A and B are complementary angle, and when A is theta, then angle B, which is basically this angle, and we got this angle as 90 degrees minus theta. Now, let's find the value of trigonometric ratio sine. So I'm going to find the value of sine. So I'll write sine A, which is what? Angle A is theta. So I can write sine A is sine theta. And sine theta is basically, we all know that sine theta is opposite. I'm going to use O for opposite. Opposite over hypotenuse. And look at this. What is my opposite? My opposite is BC. So I will write BC over my hypotenuse is AB. Right? So, in other words, I can write sine A is theta. So I can write sine theta is equal to BC over AB. Right? And where did I get this from? If you look at this expression right here, we got it from here. So I'm going to put this one in a box so that we can use it in a minute. All right? Now, let's try to find the value of cosine B. So I'm going to find cosine B. So I'll write cosine B is equal to, B is my 90 minus theta. So I'll write cosine, and my B is 90 degrees minus theta. That is equal to, and we know that cosine is adjacent over hypotenuse. And for B, adjacent and hypotenuse, they will interchange, right? Because then this will be my reference angle, right? Correct me if I'm wrong. So B will be my reference angle, and when B is my reference angle, adjacent will replace opposite and opposite will replace adjacent. So for cosine B, this is opposite and this is adjacent. So I will write adjacent over hypotenuse, which is what? My adjacent is now BC, so I will write that is equal to BC over hypotenuse is still the same, which is AB. So if you look closely, you can see right here, my cosine 90 degrees minus theta is basically BC over AB, right? Now, if you look at this expression and this expression, you will see left side is different, but the right side is still the same. What does that mean? It simply means that sine theta, this one, should be equal to this one. That is the only way we can have our right hand side equal. So since right side is equal, I'm going to write it down as sine theta is equal to BC over AB, and that is equal to cosine 90 degrees minus theta. Ultimately, what I can write? I can write sine theta is equal to cosine 90 degrees minus theta. And in the same way, if we want to prove, we can also prove that cosine theta is equal to sine 90 degrees minus theta. So this relation will be for sine and cosine. Now the next relationship that I'm going to talk about is, we can do the same thing for tangent, and the relationship will be tangent is equal to cotangent of 90 minus theta, and cotangent theta will be tangent 90 degrees minus theta. And the last one that you can prove, if you want, you can definitely go ahead and prove. You can prove that secant of theta is equal to cosecant of 90 degrees minus theta, and in the same way cosecant of theta is equal to secant of 90 degrees minus theta. So as you can see, sine theta is equal to cosine 90 minus theta, and then cosine theta is equal to sine 90 minus theta. In the same way, that relationship is also true for tangent, cotangent, and cotangent and tangent. And in the same way, the relationship is also true for secant and cosecant and secant. So basically this relationship right here, the one that we have right here, this relationship is known as trigonometric ratios of complementary angles. And you know why? Because A and B right here, A and B are two complementary angles, and A is complementary angle for B and B is complementary angle for A. And this is how we can establish the relationship of trigonometric function of complementary angle.